Hello, my name is Travis Emery. I'm a principal engineer here at Physical Sciences. Thank you for taking some time to listen to my tech talk today. The Office of Naval Research has asked Physical Sciences to develop a compact device that reduces flow disturbances inside of shipboard piping systems. To this effect, Physical Sciences has developed a decorrelator. This is a passive device that minimizes flow distortions in order to enable more compact piping systems without introducing added risk of increasing flow meter error or reducing pump lifetime. Physical Sciences is a small business located just north of Boston in Andover, Massachusetts. For over 45 years, we have developed innovative solutions for numerous DoD customers. We have a multidisciplinary staff that allows us to tackle even the most complex problems and generate working prototypes for commercial application. Working with corporate partners, Physical Sciences then establishes a commercial business, a joint venture, or a licensing arrangement to promote rapid technology transition. Our success in this process has led to us winning the second highest number of SBIR awards in the history of the program. One notable example is an aviation fuel monitoring system called the AutoGrape, which is currently fielded on Navy aircraft carrier. This system was successfully developed and transitioned by PSI in order to reduce fuel sampling workloads by 3,200 hours per month, equating to roughly $1 million per year per aircraft carrier in savings. In the current program, Physical Sciences is addressing a challenge the Navy is currently facing as they develop the next generation of attack submarines through the SSNX program. This program will strive for faster, deeper, and more capable ships that may force innovation in piping system designs. With space on board submarines coming at high premium, more compact piping systems are needed. The challenge in making these systems more compact comes from flow-sensitive equipment such as pumps and meters. These devices require consistent, developed flow in order to function properly, a condition typically achieved using long lengths of straight pipe. The problem is that this straight length requirement negatively impacts ship packaging if the space is even available to begin with. The focus of this program is to create a device known as a flow conditioner that would reduce the straight pipe length requirement to enable more compact piping systems without adding risk to flow-sensitive component performance. The program requirement was to reduce the straight pipe length requirement by at least 50%. Pipe flow disturbances can come from a number of common sources found on submarines. Bends, elbows, T's, valves, and many other components commonly used in piping systems will cause flow disturbances to the fluid moving through the pipe. One major effect these disturbances have when introduced in a flow meter is increased error. The graph in the bottom right shows some experimental data taken by Physical Sciences that shows a case where these flow disturbances cause over 30% error in the flow meter measurement. This may seem insignificant at first, but in practice, this could be coolant flow rate for a critical system where the increased measurement error would increase the risk of thermal failure. The other major effect is on pump performance. When distorted flow enters a pump, the uneven flow can cause increased pump wear, which decreases pump lifetime and leads to additional maintenance needs. To completely dissipate flow distortions, the required straight pipe length can be exceedingly long, reaching 15 times the pipe diameter or more. A flow conditioner, such as the decorrelator, can be placed upstream of these flow-sensitive devices to provide drastic space-saving improvements. The decorrelator is a passive metal device placed inside a pipe that can take highly distorted flow and turn it into uniform, developed flow, as shown in the figure on the top right of the slide. The decorrelator is able to achieve this effect in a much shorter distance compared to a straight pipe alone, typically reducing the length requirement from 20 times the pipe diameter to just 5 times. The device works on a volumetric flow basis rather than introducing turbulent mixing, which allows it to operate over a wide range of flow conditions to reduce distortions. It uses stream tubes to redistribute and straighten the flow into a fully developed condition. This methodology also means it introduces minimal pressure drop to the system, so it doesn't significantly hinder the flow into the downstream pumps and meters. Physical Sciences has conducted rigorous experiments, simulations, and analysis in order to optimize this design to achieve the best possible effects. The decorrelator program recently finished up its 4th round of funding after 3 years of development. In the first few rounds of the program, Physical Sciences has conducted extensive testing to refine the decorrelator geometry and demonstrate the flow conditioning performance. We built a custom flow loop to quantify this performance under a wide range of operating conditions. Intense, iterative development has led to the product we have today being highly capable at removing flow distortions. In the later rounds, Physical Sciences conducted manufacturing, scale-up, and integration studies. Through this, we have identified the best means of producing the decorrelator at various production and size scales, as well as several options for integrating it onto a shipboard system. More recently, Physical Sciences has engaged with the submarine manufacturer Prime to help develop our transition pathway. While we have thoroughly demonstrated the flow conditioning performance capabilities of the decorrelator, the more recent focus has been on identifying and conducting qualification tests it will need to pass for shipboard use. Subsequently, we are now seeking matching funds for a Round 4 option program that will focus on this qualification testing. The key advantages brought forth by the decorrelator stem from its ability to reduce straight pipe length requirements down to 5 times the pipe diameter. Technically, this device is able to significantly reduce the swirl in the flow and produce fully developed flow for a minimal pressure drop cost, having a flow coefficient of 120 or greater. In more useful terms, this means that water flowing through this device at 120 gallons per minute will produce just 1 psi of pressure drop. This flow conditioning has a cascading effect that improves the reliability and lifetime of flow-sensitive equipment such as pumps and meters. This in turn helps ensure the accuracy of flow monitoring systems, reduce maintenance requirements, and enables a more compact piping system. Less arrangement space required for piping systems opens up room for additional equipment to be deployed on the Navy vessel. Practically, this device can operate in pipes ranging from 2 to 14 inches in diameter with large fluid flow rates or small. The decorrelator can be tuned for a specific type of flow disturbance, or a universal one-size-fits-all version is also available. Physical Sciences has begun planning the decorrelator's transition to fleet and has engaged with General Dynamics Electric Boat, a submarine manufacturer, to better understand their flow conditioning needs. In our discussions with Electric Boat, it became apparent that the Columbia-class submarine was too far along for this type of technology development to be integrated. Instead, Electric Boat indicated that the Next Generation Attack Submarine, or SSNX, would be a better transition target. From a flow conditioning perspective, Electric Boat confirmed that the key performance parameters, or KPPs, that Physical Sciences has used to evaluate our device are appropriate. The key focus that needs to be addressed further is qualification testing. Although procurement for SSNX will not begin until the mid-2030s, extensive qualification testing is a lengthy process, so the technology maturation process will need to begin now to meet this transition target. There are many different types of qualification testing that need to be considered, which relate to corrosion, fatigue, shock and vibration, acoustics, and biofouling, just to name a few. Up to this point, we have primarily focused on demonstrating the flow conditioning performance with these in mind. Now, we need to more explicitly demonstrate the decorrelator's durability under expected working conditions in order to continue the transition process. The 4th round of the decorrelator program recently concluded with the end of the 2022 government fiscal year. We left off this work after identifying some of the most critical qualification tests and outlining test plans to complete them. In order to continue this work, funding for a Round 4 option program is available, but it requires matching funds of $500,000 or more from a non-SBIR source. The main focus of this option program would be on continuing the qualification efforts and demonstrating the device durability. There would also be some effort devoted to continuing the manufacturing and integration development that was started earlier in the program. Since the SSNX program is just starting, the associated program office is only just forming. As a result, specific vendor research and development is not currently being funded through that office. As a result, Physical Sciences is currently seeking alternative options for that funding match that will allow us to continue this work. Once this technology is transitioned for submarine use, Physical Sciences will also look into other Navy application areas, such as surface ships and unmanned underwater vehicles, or UUVs. There's also a market for flow conditioners in the oil and gas industry. In this field, there is an enormous volume of fluid transport, so the flow meter errors I previously noted can result in large monetary discrepancies. Thank you for taking the time to listen to my tech talk. Please reach out if you have any flow conditioning needs. We'd be happy to discuss what the decorrelator can offer for you. For any technical inquiries, please contact myself, Travis Emery, or the Deployable Technologies Area Manager, Sean Torres. For business development, please reach out to Jim Glynn, our Vice President of Corporate Initiatives. Thank you, and I hope you enjoy the rest of your day.